Yes.
D is not a real number.
D is not a real number. It's not a whole number. Okay. Yes, sir.
D, but they're the same number.
Yeah.
They're like the same places. With different operations.
Yep.
That get you different.
Yep.
That's important.
Good one. All right. So the only other thing that we haven't mentioned is the fact that when you multiply, you get a big number. You add, you get a bigger-ish number. And then you get a smaller number when you subtract. You get a tiny number when you divide. Okay, first of all, don't get me started. Don't get me started. So let me live my best life. Okay. So today we are going to investigate closure for polynomials. So what I would title your page is Closure for Polynomials. Yes, sir. I'm gonna have the YouTube stuff. Just pay attention. Yep. I do not want you to write down every single word. Okay, I'm gonna try to summarize it for you in just 1 second. You're gonna notice a pattern in a second. Oh, really quick. What is an integer? Anybody know? A number. What specifically was a number? Okay. So a whole number that is not a fraction and it could actually be negative or it can be positive. Okay. 0 is included in this. So any normal number, that's nothing crazy. So for instance, if I multiply 2 integers, will I always get an integer?
Yes.
Yeah. Okay, so that's a true statement. But when you write this down, you're gonna say multiply integers gets an integer. Multiply integers gets an integer. Please don't write down every word. Please don't take a picture because you're never gonna look at it again. Okay. I was that kid. Okay, so if you add 2 integers, will you always get an integer? Okay, if you say no in these next couple of statements, you gotta give me an example. Okay. Yes. Okay, if you add 2 integers, you're always gonna get an integer. Okay, you add 4 plus 5, you're gonna get an integer, etc. Now, if you subtract 2 integers, do you always get an integer? Yes. Okay, again, if you give me no, you gotta give me an example. Anybody got an example of when, if you subtract one integer from another? Go ahead. That would be negative. That still counts as an integer. Yeah, that's okay. Okay, so this is a true statement, right? So when you subtract integers, you always get an integer. With me so far? Pretty easy, not too bad. All right, now even numbers. What are even numbers?
2, 4,
6, 8. Okay. All right. Is 0 an even number?
Yes.
Is 0 an even number?
Yes.
Okay, what's the definition of an even number?
A number can be divided equally. Or like our kindergarten teacher said, if everybody has a partner, that means that it's an even number. If it's 0, there's no partner, that means that nobody's left.
If you can help us just period. Oh, okay. That is so good. Okay, technically, by definition, 0 is an even number because if you take 0 and you divide it by 2, it's an even number. Okay, so put down things. All right. So if you add 2 even numbers together, you're going to get an even number. Okay, 2 plus 4, you're going to get 6. 4 plus 8, you get 12. You're always going to get an even number. Okay. If you subtract an even number from another even number, are you always going to get an even number? Yeah, because that works both ways, right? Subtract even number, you get an even number. If you add 2 odd numbers, do you always get an odd number? Give me an example. 9 plus 3, 3 plus 3, etc. Huh? 5 and 5. Okay. 7 plus 7. Okay, so you get the point, right? So this is not true. Okay. What if you subtract an odd number from another odd number? You always get an odd number? Give me an example. 7 minus 7. Give me an even. Okay. 3 minus 1. That's going to give me an even number. Okay. So this is also not true. Okay. What if you multiply two even numbers? Are you always going to get even numbers? Yep. What about multiplying odd numbers? You get an odd number. Okay, if you say no, you got to give me an example. Yes, sir. Yes, ma'am. If you multiply two odd numbers, will you always get an odd number?
No.
Give me an example. Is there any instance? Always get an odd number. Okay. So looking at these, I want you to write down, kind of like summarize it. Okay. Don't write every single word that's on this page. Okay. I'm gonna be real with you for a second. So basically to kind of summarize this, even numbers, integers, they follow these statements. Odd numbers are the oddball out, right? They're a little weird. Yeah. Catch it? Okay, cool. Great. Thanks, guys. Okay. So now we're going to look at examples of polynomials. No, you don't have to write all those down. I'm so sorry. Okay. Which one of these, just tell me the letter that is associated with it. Which one of these is a polynomial? Polynomial.
N
Okay.
or Z.
Okay. Okay. Any other ones?
No.
Okay, why did we pick M, C, and Z?
Because they have multiple. longest.
They have more than one. They have multiple exponents. Okay, so polynomial, if you did not know, is more than one term. Okay. Fun fact, monomial is 1, binomial is 2, trinomial is 3, and polynomial is anything more than 1. Okay, so that's why we didn't count A, X, Y. Okay. Don't we all? Okay, so experimenting with polynomials. So today we're going to work on finding the answer to these two questions. If you add or subtract two polynomials, will you get a polynomial? If you multiply two polynomials, we always get a polynomial. I want you to write those two questions down. So on the following slides, we're going to use the cards to either add or subtract or multiply. We're going to pick any two polynomials of your choosing into the chart and apply the operation described at the top of the slide. Record your answer in the text box below the pair of cards. So take a second, you're writing those. Okay, so tell me two polynomials. We're going to add them together. And we're going to see if we get a polynomial. Okay, so tell me a polynomial. Go ahead. X to the third power. Okay. And we're going to add that to why you pick the complicated ones? Okay. So when we add these together, keep in mind that you always want to have your biggest exponent going first. Okay. So looking at this, what's our biggest exponent? X to the fourth. Can we add that to anybody? No. We're just going to write that junk down at the bottom, right? So we're going to say negative X to the fourth. What's the next highest exponent? Can we add that to anything? No, we're going to bring that guy down. All right, what about the next one? Okay, so we got negative 7.5 X to the second. And then we got that little 2.53 X chilling out here. So we had two polynomials. We added them together. What did we get? Okay, so it worked for trial 1. X squared minus 9. What's the other one? 1.2 x to the 8 minus x to the 7. Okay, when we add these together, remember, we put the highest exponent first. So we go 1.2 x to the 8 minus x to the 7 plus x squared minus 9. Do we get a polynomial? Yes, it works for child 2. So Blessing brought up a good point. What if we had some nonsense like this? We had, you ready? Okay, we had something like x to the 3rd minus x squared, and we added it to negative x to the 3rd plus x squared plus 1. If we simplify this, what will we get? 1, right? Is that a polynomial? No. So does this always work? No. Okay. So it does work in some instances, but not always, right? And on our question, it said, hey, does this always work? So not always. Okay, let's go ahead and look at subtraction. It's gonna be very similar to addition. Okay. When we subtract, we're gonna actually use the same numbers. Yeah, let's go ahead and use the same numbers. Okay, so we're gonna use the same numbers for subtraction. So we're gonna change the operation. All right, so when we subtract, notice how I'm adding a bracket around the second one. All right, so we've got a subtraction sign in between. So remember, the first thing we do with subtraction is we distribute that negative to each piece inside of that bracket. Okay, that's gonna switch the sign of everything that's over here. So I'm gonna rewrite this. I'm gonna have x to the 3rd minus 7.5x squared minus 2.53x plus x to the 4th. When I write out my final answer, I want it with the highest exponent first. So that's going to be x to the 4th plus x cubed minus 7.5x squared minus 2.53x. Ta-da! I had two polynomials. I subtracted them. I got a polynomial, right? We're going to do the same thing on the next one. When we distribute this guy, we're going to get x squared minus 9 minus 1.2 x to the 8 plus x to the 7th. When I write out my final answer, I'm going to get negative 1.2 x to the 8 plus x to the 7th plus x squared minus 9. Would there ever be an instance where we would not get a polynomial? When?
When they cancel.
Like if it's the same thing when they cancel out? Okay. Anything else? Okay. So there would be an instance where we would result in a monomial instead of a polynomial, right? So again, we're running into the instance of not always, but sometimes. Yeah. Anybody writing anything down? Okay, cool. All right. Looking at the next one. Okay. I want you to pick two that you want to multiply together. Okay. So if I were to multiply polynomials together, let's just kind of think through this together. If I were to multiply polynomials together, would I get a polynomial? Why?
There's multiple terms.
Okay. Yeah. Is there any instance that it would not work?
When you multiply the polynomials by the inverse of the polynomial.
You're talking about like the conjugate of it? Okay. So like if I had x plus 2 times x minus 2, if I multiplied that out, I would get x squared minus 4.
What if you did negative x? Like, yeah, you did like, no, you made the x and the x minus 2 out, and you like made it. There's still be negative x squared, like right here.
You still have still negative x. Okay, so this one will always work, right? We will always have a polynomial. If you start off with two polynomials, you will result in a polynomial. Okay. Oh, I'm sorry. All right, let's summarize really quick. When adding two, my goodness. All right, when adding two polynomials, the sum is sometimes a polynomial. Okay, when subtracting, the difference is, okay, when you multiply. Okay, so let's talk really quick. Ready? What'd you get for number one? True or false? False. And the reason why is because that exponent is not correct, right? Okay. You should have gotten 7x plus 8. Okay. On the next one, did you get true or false? False. It's false. You should have gotten 5x squared minus 5x plus 5. Okay. Hey, I'm doing math over here. Okay, thanks. Hey, when you multiply the next one on number 3, did you get true or false? True. Okay. On number 4, did you get true or false? False. Okay. When you distribute all that out, it does not work out. I don't really want to do this part. This gives me 4x cubed minus 20x squared plus 12x plus 8x squared minus 40x plus 24. When I simplify that, that's going to give me 4x cubed minus 12x squared minus 28x plus 24. Again, that's not correct. Okay. Yes, ma'am.